Texan Global School. Circle. In this class, the equation of the circle is analyzed in canonical, standard and general forms. By definition, a circle is a locus of a point in the plane such that it is always at a constant distance, called radius, from a fixed point called center. Using this definition, let's start from a point P, with coordinates x, y, of the circle, whose center is the point C of coordinates h, k, and whose radius is the constant r. The point P must satisfy the condition where the distance, called radius, from the center to any point on the circle is always constant, this is, r is always equal to the length of the segment C, P. Using the formula to obtain the distance between 2 points, calculate the radius, or distance between points P and C. When substituting values in the formula, results that the radius, r, is equal to the square root of x, minus h, squared plus y minus k, squared. So, we obtain the equation of a circle in standard form, whose center is the point C, with coordinates h, k, and radius r. Let's look at the first example. Find the equation of a circle in standard form, whose center is the point C, of coordinates 1, 2 and radius equal to 2. In this case, we can graph directly. So, start from the center, C, of coordinates 1, 2. Since the radius is 2 units, and by definition it is the constant distance from the center to the points of the circle, the quadrants through which the circle passes are the points 3, 2, 1, 4, -1, 2, and 1, 0. Now, substituting the values of the center and the radius into the standard form, results x minus 1 squared, plus y minus 2 squared equals 4. This is the equation of the circle in standard form whose center is 1, 2 and its radius 2. If we now move the center, C, of coordinates h, k, to the origin, that is, to the coordinates 0, 0. By substituting into the equation of the circle in standard form, we obtain x squared plus y squared equal to r squared. This is the canonical form of the equation of a circle. For example, we will find the equation of a circle whose center is at the origin and radius 2. Let's graph the circle, as it goes through the quadrants 2, 0, 0, 2, -2, 0, and 0, -2. Now, to obtain the equation, substitute the radius 2 in the canonical form. In this way, results the equation x squared plus y squared equal to r squared, which is 4. If we algebraically develop the equation of the circle in standard form, results the so-called general form. This is done using special products, developing the square of a binomial as a perfect square trinomial. X minus h squared results x squared minus 2x h plus h squared. Y minus k squared results y squared minus 2y k plus k squared. Now, group quadratic terms, linear terms, and independent terms. So we can assign values like d equal to -2h, e equals -2k, f equals h squared plus k squared minus r squared. So, we have the general form of the equation of a given circle as x squared plus y squared plus d x plus e y plus f equals 0. We will use the previous example to find the general form. Find the equation of the circle in standard and general form, whose center is the point C, with coordinates 1, 2 and radius equal to 2. One way to obtain the general form is to first find the standard form as seen above. Substituting center and radius values in the standard form, results x minus 1 squared, plus y minus 2 squared equals 4. Developing the square of a binomial, we obtain x squared minus 2x plus 1, plus y squared minus 4y plus 4 equals 4. Grouping quadratic and linear terms and simplifying like terms results x squared plus y squared minus 2x minus 4y plus 1 equals 0. This is the equation of the circle in general form. Another way to obtain the equation in general form directly from the given data is by substituting the center and radius into the derived formulas. Hence, by substituting values we obtain that d is equal to -2, e is equal to -4, and f is equal to 1. By substituting in the deduced general form results the same equation. Finally, to transform from the general form to the standard form we will use the method of completing squares seen in the algebra course. First, in case the numerical coefficient of the quadratic terms is different from 1, we must multiply both members of the equation by their multiplicative inverse to make them 1. In the case of a circle, the numerical coefficients of the quadratic terms will be 1 or will have exactly the same value. Then, we must send the independent term to the right side of the equation. Now, group according to x and y. Then, multiply the numerical coefficient of the linear terms d and e by 1/2 and square the result. We do this for each of the variables, that is, twice. The values obtained must be added to both sides of the equation. In this way, two perfect square trinomials are obtained. So, factor and develop the right member. As a result, we complete the squares to transform the general form to the standard form. Comparing the standard form, we can see that the numerator must be greater than 0, the center has coordinates -d over 2, -e over 2. And the radius is calculated as the square root of d squared plus e squared minus 4f over 2. Let's look at an example. We will obtain the standard form of the general form obtained in the previous example. The equation is x squared plus y squared minus 2x minus 4y plus 1 equals 0. Follow the described process. The numerical coefficients of the quadratic terms are equal to 1, so we move on to the next step. Send the independent term to the right side of the equation. And group according to x and y. Then, multiply the numerical coefficient of the linear terms by 1/2, and square the result. So, -2 times 1/2 squared is equal to 1. And -4 times 1/2 squared is equal to 4. Add those two values to both sides of the equation. On the right side, we have completed the two perfect square trinomials. So, factor as square of a binomial, and develop the right side. We can see that we obtained the same standard form, x minus 1 squared, plus y minus 2 squared equals 4. Which is graphed as a circle whose center is 1, 2, and radius of 2. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com